So welcome to my talk. Welcome to the Flagship channel. I'm Folini. I have 15 years of experience running ModSecurity in production. And as Lucas just introduced me, I'm the co-lead of the OWASP ModSecurity core rule set project. In this talk, I'm going to introduce to core rule set, or CRS as we call it. I'm going to show you a few key concepts, what we're currently working on, what is going on in the community, what the future may hold for CRS, and how you can join the fun. So let's dive right in. CRS is a distribution for ModSecurity. It's a rule set for ModSecurity or a ModSecurity compatible web application firewall. It's a set of generic attack detection rules to protect you from threats and risks, namely those as described in the OWASP top 10. Safety belts. I reckon almost everybody in the audience is wearing a safety belt when driving a car. You're not driving around without safety belts most of the time. And you don't do this because you know that a safety belt is protecting you from going to an accident or from protect you from any harm should an accident actually happen. No, you're wearing a safety belt because it reduces the harm and because it gives you a certain protection when an accident happens, when somebody bumps into you or a tree stands in the way, as in the photo. So safety belts are no silver bullet. They're just one of several safety measures in your car. So the return on investment is positive for a safety belt. It's relatively easy to do, and it protects you to a very good extent. So it's useful to wear a safety belt. And the same is true for a web application or CRF to be exact. It will not protect you from every security incident, far from it. However, it has good baseline security. It gives a good return on investments, and you should apply it to give you better sleep and to make it harder for an attacker to exploit your services. So this is all based on ModSecurity or a compatible web application firewall engine. ModSecurity is embedded, it's inline in the traffic, it is rule-oriented, and it gives you granular control. So this is no artificial intelligence, machine learning, next generation cloud-enabled super mastermind. This is honest piece of engineering that brings you a mechanism to deploy rules, and rules will then do pattern matching on the traffic and decide whether to block or let a request pass. So it's relatively transparent. I'd say it's very transparent, but it takes a bit of knowledge. And then you can get this running. So ModSecurity is the engine, and then we put the core rule set CRS on top as the next piece of the stack. And does it really work? And how does it work? Let's take a closer look. Here you see Burp attacking a vulnerable application. The application in question is vulnerable on purpose. It's a testing application that is deployed to see whether a security scanner like Burp is able to exploit it, whether Burp is able to discover all the weaknesses in the application. So Burp here executed over 4 million of requests against this vulnerable application. With roughly 1,000 of the requests, Burp reported, hey, guys, I think I found a weakness. I think this is exploitable. In the end, this boiled down to roughly 40 weaknesses. So 1,000 hits where he found a weakness and 40 root causes of these weaknesses. That is the first column. The second column is a default installation of CRS 3.0 to be exact. And that is the 5-minute installation. That's just app get installed, off you go. And that brings you that positive effect. Roughly 80–90% of the weaknesses are gone. Put it concretely, SQL injections are no longer exploitable for Burp. Local file inclusion, remote command executions are mostly gone. I'm not promising you that a skilled attacker, a really smart mind, is not able to pull off an SQL injection. Well, a really smart attacker is still able to pull off an SQL injection. But Burp An automated scanner is no longer able to do it. It takes brains now to pull this off, and this takes time, investment, and resources. So the easy, simple attacks are gone. And this frees your mind to concentrate on the more advanced stuff, of the rest of the OWASP top 10, social engineering attack, business logic flaws that you may have in your application. So again, CRS is not freeing you from protecting your application. Source code, clean source code, fixing your bugs, deploying latest versions, supply chain security are still important patterns. What we bring you is another piece in your application defense, another piece in your security program, a first layer of defense. So the script kiddies are gone, the simple attacks are gone, the worms and the trojans are no longer able to exploit you. This buys you time, and it buys you a free mind so you can concentrate on the things that are really, really relevant. Good. So there comes additional columns, and I'm going to return to those called paranoia levels as we move along with the presentation. Good. Next, here are other numbers assembled by Tuomo Makkonen in a blog post. You want to maybe follow me on Twitter. I'm linking these resources on Twitter. The address is in bottom left. As we move throughout the presentation, I'm linking these resources so you get them on your desk or your mobile phone. So Tuomo Makkonen tried to find out how good are various commercial cloud offerings when it comes to the detection ability. You want to compare the red columns to the green columns. As in the green columns, CRS is always involved. And look at the third line there, the first row, SQL injection. That confirms what I just said about Burp. The green Azure WAF CRS offering protects you against 97% of the SQL injections that Tuomo Makkonen tried out. The Google Cloud Armor CRS gives you even 99%. And even CRS and Cloudflare is pretty decent. Honestly, I don't really know what Cloudflare did to our remote command execution protection rules or the server side include rules on the top right. But what the graphic can tell you is that when you're shopping or investing in a web application firewall, then CRS is your ticket to success. Please don't let commercial advertisements fool you. CRS brings you protection. And unfortunately, the commercial competition is not up to the task. If you look at this graph, for example, the commercial competition is a joke. It might not be so much true for the Alibaba cloud that they don't really know what technology they're using. The numbers suggest it might be CRS as well, but they're not telling us, and they're not very open anyways. But definitely against the red commercial apps that are doing very good in the clouds, but they don't bring you real protection. And that is a bit of a sobering revelation. So why is that? Why is the open source offering so much better than the commercial offerings? Let me tell you a story that you know all too well. Here is a boy. Oops. Oh, wow. My share, I'm sharing my screen as a PDF, and it seems the emojis didn't come when I exported it. Let me return here. That should do the trick. So here's a presentation with emojis. So we have a boy here. You know the story all too well. It's a story that illustrates the reason and incentives why open source beats the commercial competition. So the boy is not overly happy because there is work to do. The boy is supposed to take his sheep, and take them to the forest. This is very slow. Let's just go on. Okay, so the boy has to take the sheep to the pasture and guard them against the wolf. You know the story. The wolf shows up, and the boy is supposed to to raise the alarm so the hunters come and track down the wolf. That is what we call a true positive. There is a wolf, there is an alarm, the hunters come, they track down the wolf, the sheep are protectors, the hunters are happy, and so is the boy, and everybody has a big party. Everybody is happy. Well, with the notable exception of the wolf, of course. But that is the game that you're entering when you buy a WAF and evaluate a WAF. This is what you think is going to happen. However, the problem is the detection. The boy raises the alarm. Very often, there isn't really a wolf. That is what we call a false positive. In fact, that can happen with the call rule set. There is a certain risk that sometimes this is not really a true positive. Sometimes we think we have a wolf, but then there is none. It's called a false alarm. The hunters go out, protect the sheep, but there is no wolf. The hunters get pissed. It happens, if that happens too often, the WAF will be switched off. That is very problematic. However, the alternative is even worse. And this is where the commercial competition is entering. Commercial competition will rather accept a false negative. And a false negative means there is a wolf going after the sheep and the boy does not dare to raise the alarm because he's not 200% sure it's really a wolf. The detection is hard with web application attacks. You're never quite sure. Now, the incentives for the commercial competition are as follows. If they have a false positive, if the big boss of the company is locked out of a web application, he's seriously pissed, and he might not prolong the license for the commercial WAF anymore. So there is a risk for the commercial vendor that they're pissing off their customers and that ruins their business. So false positives are seriously bad if you have a commercial offering. You're always risking to lose a customer over false positive because you promised him it's super easy and there are no problems, no false positives. And then a false positive is ruining the day, it's ruining the whole experience. That's why they would rather err on the side of false negatives. What is a false negative? A false negative means the customer might be exploited. Maybe it's only a penetration test, say, hey, look, you have weakness there, you better fix the source code. And maybe it's a real exploit. Maybe real money is lost. Now imagine a company losing real money. Will they disable their WAF? No, of course not. They will throw even more money at the commercial WAF if that happens. So actually, the commercial vendor has an interest to avoid false positive. And if it's false negative, he doesn't care too much because this will even bring in more money. Our skin in the game is completely different. We're open source developers. So what we're doing is we're spending our spare time, not enough for our families and kids, but we're writing regular expressions to protect you and your software from attacks. And if there are false positives, we really try to help you. We want you to open issues on GitHub. We try to nail it down. We try to weed out false positives, and we really have come a long way in this regard. There are less false positives than there used to be 2 years ago, let alone 4 or 6 years ago. So we're constantly improving. However, if it comes to decide whether to accept a false positive or allow a false negative, we would rather allow a false positive and run the risk of annoying you and forcing you to work in this than allow and exploit a wolf in a hoodie to attack you and your data and your assets. So this is why we think the incentives are on our side, and that's why we think the numbers are so much better for the open source WAF than for the commercial competition. Good. So how do we go about this? What is under the hood when you look at CRS? You've seen the slide with the paranoia levels. The default installation comes with paranoia level 1, which brings a minimal number of false positives and a good baseline protection. We would say everybody hosting something on the internet should run CRS with paranoia level 1. Then, when you have real data and real money involved, maybe a commercial web shop or somebody or users really subscribing to a service, anything passwords involved, or real data, real asset, real people behind it, then you should go at least to paranoia level 2. There you get additional rules And these rules are a bit less good when telling hoodies and wolves from benign traffic. So they might err on the false positive side. You should be able to help yourself in such a situation. It takes a bit of knowledge now on the side of the administrator. And that is important to actually take into consideration. This is going to need a bit of resources. Then if you raise your security appetite, when you want to have a better solution, you go to paranoia level 3. That is online banking. Level security brings you more specialized rules and more false positives. And then at the highest paranoia level, for it currently, that is meant to go for nuclear power plant level security. That is a bit tongue-in-cheek, but there is actually a high security setup running paranoia level 4 in Switzerland for an online voting system. And I'm going to present tomorrow in Rome at Rome Hack 2021 about that system and how they pull off a paranoia level 4 system in production. And it's perfectly doable. It just means you need to weed out a lot of false positives because these rules are really crazy and they're super aggressive, and they will tear a benign user into pieces unless the rules are trained, the WAFs is trained, and the false positives are tuned away. And that is the work of the administrator that we can protect you with. We're going to turn to you to that on the next slide. So false positives are there and they're haunting you, and you need to get rid of.
They're expected from paranoia level 2, and you have to fight them with so-called rule exclusions. On the right, you see a cheat sheet here. It shows you 4 conceptual variants to fight false positives. There is a very good rule exclusion tutorials at my company's website, netnea.com, and there is also CREX, a rule exclusion software that we run at NetNea. Look into it if you're haunted.
So anomaly scoring, that is a methodology that actually works in production. You reduce the anomaly threshold gradually, and as you move down with the limbo stick, the stormtroopers, it gets harder and harder for the attacker to fit underneath. So the adjustable limit and the iterative tuning makes it easier for you to move into a CRS setup in blocking mode. Next concept, the final concept we're going to present to you, the sampling mode. I don't know why commercial software is not offering that. Commercial apps are not offering such a service or such a feature. With the sampling mode, you can define for CRS to inspect only 1% of the requests coming in. So you have a working, a productive setup, and you add CRS for 1% of the requests to see what's going on. If it fails, then it only fails for 1% of the user. And if the performance is very bad, then it will not kill the server because it's only 1% of the users affected. So you can tune your system, maybe roll back, or you're happy with the setup, and you slowly raise the sampling to 2, 5, 10, 50, and ultimately 100%. So that really works. You can ease into a situation, into a setup without risking to piss off your users again. As the anomaly scoring mode that lets you guide or take one step after the other, be iterative, so you always remain in charge, in control of what is happening. Good. Next slide. What about our project now? When my predecessor as a leader took over in 2015, he was more or less alone. In 2016, my current co-lead, Walter, joined, and we took the release to CRS3. So we took the project to CRS3, the big major release, where we actually started to fight false positives, and we introduced these paranoia levels that I explained to you. And the anomaly scoring was now the default. This attracted a large numbers of new developers, and ever since we have a steady streams of new developers. We're 14 of us now, a very diverse group, spread over 3 continents, and we're very happy to have women in our ranks. One of our strongest engineers, Franziska from Switzerland, as I am, and we just promoted 3 developers to become active developers with commit rights on our GitHub. Of the 14 people listed here, 11 have contributed code in the last 2 months. So this is really an active, a fairly big OWASP project, contrasts to this many smaller OWASP projects where there is a one man fighting along for his own project. You guys in the audience, you should really join these projects and support them. Or you join us, because we have a lot of fun and we're a large, growing number of friends working on this together. And we have very good meetings. We do cool stuff together. We have features to support each other's. And it just feels so different from other open source projects I've run before, but it was such a struggle. So this is, compared to it, this is a bit of a, I wouldn't say a walk in the sunshine, but almost. Next thing going on is what we call the Dev on Duty program. The Dev on Duty program means that one of our 10 or 14 developers is active on duty 7 days a week. And he or she is doing first level support on a number of channels. So this is free software, this is open source software, but you're getting free support, free at least first level support on several channels. So of course, covering our GitHub, new issues coming in, within 24 hours, you guarantee to get a response. We're covering Stack Overflow for CRS questions, but we're also covering ModSecurity keywords and Stack Overflow and the various sister sites. We're of course looking at the CRS and ModSecurity mailing list. And starting October, we're going to expand our Dev on Duty program to Twitter, where we will also include ModSecurity keywords and questions asked on Twitter, because nobody's doing that right now. Thanks to our sponsors, we can expand this to $200 US per week of duty for our Dev on Duties. So we're in a thankful position to have real sponsors, and we can now bring our developers in to support our community with that money. I think that's a very, very welcome development, and that supports all the CRS users, of course. Next up, at the end of October, is our developer retreat. We've done this before around OWASP conference, namely the OWASP Europe conferences, where we met for a day or two and hacked away. This time, we're going to retreat for a week, again sponsored by one of our gold sponsors. And for 7 days, we'll retreat to this little hotel in Switzerland, right in the Alps, with 10 developers and 1,000 ideas what you can nail down or get done within a week. Whenever we meet, it's like an explosion of our mind. There's so many ideas, and we contribute to each other, we inspire each other, and we're working like mad. And I'm sure this first time meeting of 10 active developers will be a huge success for us and for the project. So this is at the end of October. And what else is going on in current development? We're very active in keeping the number of open issues though. Most of the open issues that we're getting are false positive. And we really try to help our users as fast as we can, weeding out false positive. We immediately tell them how to do a rule exclusion, so they get rid of it immediately. But then we also try to fight this false positive, so future users after the next release are no longer exposed to that. And that is probably the biggest ongoing work in the project. We went down from over 150 open issues to as low as 27, and that's about where we want to get at, because there is a certain time that it takes an issue to run through multiple stages until we have a working pull request that can be merged. We're developing a plugin mechanism that's almost over now. We want to move certain exotic feature out from CRS into separate plugins. The plugin mechanism will also allow third-party plugins to plug into CRS. So you can bring your own rules and join the scoring fund, or do your own rules on Paranoia levels. And that makes it more open to work together with us. And it lowers the bar for new interesting rules that we were probably not allowing to the mainland distribution. That is really strict what we want to do there. But we're open to accept plugins to do more creative things, more risky things perhaps. And that allows for experiments that may ultimately come into mainstream or not. So this is like CRS for everybody. Very cool. The underlying web servers that we're protecting are not very good when it comes to all the new request modeling, server-side request forgery attacks that Portsmouth guys, Burp, and many others are bringing up. And and publishing at conferences and in blog posts. And we want to see if we can improve the situation there. There are certain things that OWASP cannot do, but we're convinced that we can do better than the current status. We're sure that we can improve that, and we can improve our rules, and we're doing a concerted effort there, probably at our developer retreat at the end of October. We're going to set up a usable demo site, so everybody, namely security researchers, can try out their payloads, and ideally, they would try their payloads, and when they publish, they will also add a slide and say, hey, look, CRS, by the way, already protecting this. Why is your software affected? So that is the ultimate goal with that. And we would learn a few payloads that way as a second benefit, of course. We're thinking about using some of the sponsoring money for bug bounty. So we would get hold of new false negative things slipping underneath CRS, and we could then write new rules for it. So that would be really beneficial. And we're also looking into more rule exclusion packages for well-known software. We do hold a dozen of those. So when you run something like Drupal or Joomla, PHP, MyAdmin, or a WordPress, there is a rule exclusion package that anticipates well-known false positives. And we want to expand that also to plugins, because most people are not running a naked WordPress. So that is still where to go. I'm slowly coming to the end of my presentation now. Here is the summary. CRS is a first line of defense against web application attacks. It's a generic set of deny rules for WAFs, namely against attacks as described in the OWASP top 10. It blocks at least 80% of web application attacks by default. It can go as high as 95, 99% if you're willing to run in paranoia level 4. ModSecurity and CRS gives you granular control over the behavior of the WAF down to the parameter level. And I think that is very, very important for a WAF, even if artificial intelligence WAFs tell you differently. We're a very happy growing developer community, and we're waiting for people like you to join us and join the fun and help us make CRS a lot better. And here are a couple of resources that are named throughout my presentation. Our website is not only at OWASP, but also at conrulset.org, where we're publishing a blog. Our GitHub is under this you see here. The numbers from Doma about the comparison between cloud WAFs and those including CRS and those without CRS, you can find under this URL. I have very good tutorials written and published at NEA.com. They're all free. And there is also CREX, the software that helps you get rid of false positive with the help of rule exclusions. I'm also running courses on CRS and ModSecurity. You find them under this URL. I'd like to thank our gold sponsor, Nginx. There is a second gold sponsor in the queue, but we haven't announced that one yet. But this is already supporting our Dev on Duty program. And you can find me on the OWASP Slack, generally today at the 20th anniversary Flagship project channel, and me and all the other developers at the conrulset channel. Thank you for joining my talk, and happy to respond to your questions there via email or on Twitter. Thanks.